This is lesson 3-7 of applied geometry. We're going to use the distance formula to find the length of a line segment in a plane, which we can do if we know the endpoints. If it's lying in a plane, we can usually find the endpoints, or if it's lying in the XY coordinate system. And sometimes you'll be given problems with figures that come later in geometry where you have to find area or perimeter, and you have to calculate the length of the line because it's unknown. You have to calculate it using a distance formula. So this has application that will come later. For now, we just look at it as a formula. And here's the formula. We don't have the tools to prove this yet, so you just have to write it down and use it as a formula for now. So let's plug in. We're finding the distance, so that's going to remain what we find. It all goes under one great big square root. All these are consistent with stuff we've already learned. We need to find the x2 and the x1. Either of those could be either, but I'm going to call this x2 and I'm going to call that x1. So it's 10 minus a negative 2 squared plus, since I called this x2, I have to call this y2. So that becomes my y2 minus my y1, then is 4, and I square that. And because I'm squaring, I end up with no negatives under here, so this is all going to be workable, which is nice. Now everything's picked out as long as we chose well. We're going to get this right. Let's do our calculations. D equals the square root of, now it's order of operations. Do everything in parentheses. I know how to handle that situation. So that's 12 squared. Plus, do this, 1 minus 4, I know how to handle that situation, is negative 3 squared. Now my final step, well, close to final step, not final yet, is to square these. You may need a calculator for this. The square root of 12 is 144. The square root of negative 3, since the negative is in parentheses, I square them. The negative multiplies as well. Negative 3 times negative 3 is positive 9. So my final answer is the square root of 153. Now this happens a lot. In fact, most of the time, you're going to get an answer that's not a nice round answer. And you'll have to use your calculator to convert it to decimal form. This is 12.369. I suggest you practice with your calculator to see that you get that. All calculators can be different. So the distance, the length of this line segment is 12.369. Whatever units we determine them to be, we'll just say inches for now. Now since this can be kind of a complex formula to deal with because of the roots and stuff, let's do another example. We're going to take the graph away and we're just going to be given, in this case, we're just going to have the points. So one of the points is negative 3, 1. And we'll call that point 1. And another point is 4, 3. And we're going to call that point 2. Let's start substituting into the equation or into the formula. Our equation is a formula in this situation. So D equals x2, I'm going to say is 4, minus, don't forget the parenthesis, x1, which is negative 3. So 4 minus a negative 3. Potential for mistake making here. Don't forget there's already a negative there, and then I bring that one in, so there's 2. Plus y2, which is 3, minus y1, which is 1, square it. Now just finish the calculation. I know what to do with that situation. 4 plus 3, order of operations, do what's in parentheses first, is 7 squared, plus 3 minus 1, do what's in parentheses first, square it. Now let's go ahead and square those numbers. 7 squared is 49. No shame in using a calculator. 2 squared is 4 if you don't know these by heart. Eventually you work with these numbers enough that you do memorize some of them, but it's not crucial that you have them all memorized. This ends up being D equals square root of 49 plus 4, which is the square root of 53. Now sometimes your teacher may say leave it in this form because this, for scientific reasons or for reasons of accuracy and precision, this is an exact answer. If we convert it to decimal form, then we end up with only an approximate answer. So I'm not going to do this in this case. I'm going to leave it in the square root form. If you want to practice converting them to decimal form, then by all means do so.